So, first of all, we have with us today John Alley of Custom Building Products. I'll read his bio. John has been a dedicated professional in the industry for nearly 20 years. For the past 9.5, he has served as the Commercial Architectural Services Representative at Custom Building Products. John is an active member of the industry's community, sitting on the board of directors for the Terrazzo Tile and Marble Association of Canada, also affectionately known as TTMAC. Additionally, John is the current director for the Vancouver chapter of Construction Specifications Canada, CSC. That's a great position to hold, John. Also with him, his wingman today is Luis Carvalho, Regional Technical Sales Representative with Custom. Luis brings over 25 years of experience in the tile and flooring industry to his work. He spent 15 years as a hands-on tradesman before joining Custom Building Products, where he has dedicated the last 10 years to supporting customers on both the tile setting and self-leveling sides of the business. This unique combination of field experience and product knowledge makes him a valuable resource for industry professionals. I know I've picked your brains, Luis, on plenty of occasions. So yeah, great to have you here. Guys, I'm going to turn the screen over to you, and looking forward to this.
Fantastic. Thank you, Chris, so much. So as Chris mentioned, we are going to be discussing self-levelers today and why not, or why all self-levelers are not created equal. So there we go. Some of the things that we are going to discuss today is the different ASTM and ANSI standards that are involved within self-leveling and how the industry itself has adapted and changed and the requirements that are needed depending on different types of installation. We're also going to touch on the difference between gypsum-based self-leveling underlayments and cementitious-based self-leveling underlayments, the different grades or types of self-levelers that exist. We're going to discuss compression, flexural, and tensile strength of self-levelers and why that's important. Different pore thicknesses and what we can expect from different types of self-levelers, the usage and why different areas may require a different type of self-leveler depending on the end result that's required. Substrates, plywood versus concrete. And then lastly, we're going to discuss moisture mitigation and movement joints. So why do we need to talk about self-leveler? Why has self-leveler become so important within the last 10 or 15 years, if not before then? And in a lot of cases, it's self-levelers become so important because the industry is moving at such a high pace and the tolerances now that exist have become significantly tighter than what they used to be. So self-levelers that we see now, they're preventing costly repairs to floors when projects can go awry. If the wrong self-leveler is selected from some of the photos here, you can see that we can run into some very costly issues. They can help correct at a more cost-effective standpoint some imperfections that exist within your substrate. It helps bring that substrate to comply with what industry and manufacturer standards are. As I said, they're getting significantly tighter than what they used to be. And it helps achieve what the desired performance of that floor is going to be, as well as it can speed up construction compared to older techniques that used to be used. So, as Chris said, Lewis's and my backgrounds are primarily tile related. So the next 2 or 3 slides are going to be a little bit more tile oriented, but they do incorporate and encompass the whole flooring industry as a whole. So why are we more concerned, or why is the concern of floor flatness more important now than ever before? From a tile standpoint, in yesteryear, when we were dealing with 12 by 12 and 6 by 6 and 8 by 8 tile, your imperfections within the substrate itself were significantly higher. We could get away with a 1/4 inch over 10 feet of rolls or curling or whatever it may be, and that was okay because the tile or the sheet goods or whatever that was going down was able to take that. Now as tiles are getting larger, as wood planks are getting larger, as the requirements for sheet goods are getting more stringent, those requirements have gotten a lot more refined and a lot tighter, where in a lot of cases at bare minimum, we're looking for an 1/8 of an inch over 10 feet. With no gaps larger no more than 2 gaps if it's involved in the tile side of things. So in a real world, this is what our clients expect. They want to see a nice, smooth, flat, level floor with no humps or dips or curls or anything like that. But realistically, when we get to site, this is what we're running into. And self-leveling can help mitigate these problems to get the substrate to a point where everyone's going to be happy. Moving to the ANSI and ASTM side of things, that once again, some of these ANSI standards are going to be a little bit more tile related. Some of these ANSI or ASTM standards are going to be a little bit more resilient related, but there is a lot of crossover between the two. Most importantly, we have ANSI A118.16. This is the new standard for self-leveling underlayments or cementitious self-leveling underlayments that now ensures that we're all playing on the same field for all intents and purposes. This was a standard that was in the works for, Lewis, you can correct me if I'm wrong, I think it was over 10 years to get it to the point. And it was recently launched 3 or 4 years ago now in 2021. You know, this lays out the basic framework for what is required from a cementitious self-leveling underlayment, what the minimum standards are for it. And I'll get into it a little bit deeper in the end, but from an architectural standpoint and a specification standpoint, this needs to now be included in those specifications to ensure that improper products aren't finding their way into the equation. Secondly, we have
John, is there much of a difference when it comes to a self-leveling product that you'd use under tile versus under resilient in a glue down resilient situation? Because of the nature of shrinkage and expansion that you get from resilient, but you don't get it from tile.
Actually, if I may, that's why they brought out the standard, Chris, is just so that everybody's the same, so that when the testing standards, for example, there are some gypsum-based self-leveling underlayments, which can cause issues with resilient flooring and may require longer cure rates, which we'll get into later in the seminar. But that's one of the reasons why they brought them out. So there can be differences in self-leveling, but following the ANSI standards, the self-leveling should be the same for all flooring types.
Gotcha. Thanks.
Yeah, I'll get into a little bit more of the minutia later on, but as Lewis said, generally speaking, as long as the cementitious self-leveler or hydronic cement underlayment meet the ANSI A 118.16 standards, then we're generally covered for any flooring installation. From the tile side of things, we have ANSI A 108.01, which is different than ANSI 108.1. This focuses more on the surface prep itself and what the tolerances are required for tile installation. ANSI 108.1 has to deal with the installation of tile itself. This is more for the surface preparation side of things. Lastly, for the ANSI side, we've got 108.21. This is for the installation of cement underlayment. So this goes hand in hand with 118.16 for classifying the type of self-leveler. This goes to how that self-leveler has to be installed. From the ASTM standards, we've got ASTM C1708, which once again, this is test method. So this is how we're going to achieve what's required off ANSI 118.16. And then the standard that we all know and love, and yes, it is resilient focused, but as we were discussing before this presentation, pretty much all flooring options resort back to it or look at it, is ASTM F710. So to kind of capitalize on Chris, what you were just saying and what Lewis was alluding to, the major types of self-leveling underlayments that exist are either gypsum-based or cementitious-based. Now, cementitious-based, we can break even further down by going, is it a Portland cement or a primarily Portland cement versus calcium aluminate, but that's a whole separate rabbit hole. Generally, for the two major differences, we've got a gypsum, which, depending on how thick it's being cured, can have longer cure times. One of the downsides or possible concerns with gypsum underlayments is, depending on the thickness, depending on ambient air and moisture concerns, they can have drastically extended cure times before your flooring can go over. One of the manufacturer's technical data sheets that Lewis and I were looking at recently, for an 1.5-inch pour, they're saying that a flooring can't go down for 14 to 17 days, which that can really slow down a project. On the surface, gypsum underlayments can be more cost effective, but understand that there may have to be some additional prep that goes on after that that gypsum self-leveler has gone down. One of the major selling features with gypsum is its sound control characteristics that are built into it. Gypsum has a fantastic ability to help deaden sounds, and that's why we see it a lot in wood frame construction, where IIC and STC requirements are a big concern that exist. It is a lightweight product. One of the other things with gypsum is it does not have an ANSI standard, so it can vary on water level and flow rate and general makeup of the product itself. From the cementitious side of things, sorry, Chris.
Sorry, John. Is there an ASTM that guides gypsum?
Not that I was able to find.
Such a
if there's an
problem.
expert, yeah, if there's an expert out there that knows differently, I would love to hear it. But from my knowledge and the research that I've done over the years, I've not been able to source a standard for it.
Yeah,
If anyone, I thought Clayton would probably jump in on this one. Yeah, I know where Lewis is going with this. Generally speaking, you have to meet 2000 PSI strength. That's the industry standard for minimum compression strength.
But no ASTM or ANSI to guide placement in indoor environmental conditions to guard against separation of the ingredients within that product. It's such a problematic product, yet such a great product at the same time.
Yeah.
It surprises me that there's nothing there to generically guide the installation and use of it.
Yeah, and one of the biggest challenges with the gypsum based is they're typically site mixed. So you have several different raw materials, you're blending on site and then pumping. Where if you're not managing it correctly, it can easily go awry, right? And you can end up with weaker substrates.
Yeah. God, I've seen some nightmares, and the poor builder just caught up in.
Yep. Yeah, and more typically
50,000 feet.
Yep, and typically more susceptible to cracking as well.
Yeah. Interesting.
Yeah. From a very generic standpoint, and it goes back to the second point with gypsum being a more cost-effective solution to level your floor. I'm going to use very generic numbers here, but generally you're around that $1.50-ish a square foot. However, be aware, as I said, gypsum underlayments, generally speaking, are going to need some additional prep work after the fact to ensure that either a tile can be bonded to it, or a resilient floor or hardwood can be bonded to it. Especially as Lewis alluded to, because it's site mixed, we may not be able to meet that, or it may not achieve that 2000 minimum PSI compression strength.
But you wouldn't use gypsum as a patching material. or well, correct me if I'm wrong, but so the title of this slide suggests that, the cementitious products that we use to patch and bring flatness to an already poured slab might be something that you could use gypsum for as well, but I don't think so, right?
Yeah, correct. Yeah. Yeah, and also the other thing with gypsum too is they're typically interior only, dry areas only with gypsum self-leveler.
Yeah.
So moving on to cementitious. Once again, this can be Portland or calcium aluminate. Generally, the industry as a whole is moving to calcium aluminate for multiple reasons. It's got a better dimensional stability. It's less likely to curl or crack or anything like that. But there are still some holdouts with old Portland cement based, cementitious based. But just generalizing here, it's got a stronger cure strength. Once everything is said and done, it's far more moisture resistant than gypsum based. It's stable for both wood and concrete substrates. And then once again, it falls under that ANSI 118.16 standard. So it's now governed. Michael, in regards to your question there that I just saw, as I said, I'm generalizing numbers here, so I'm not going to get into specifics on cost. It has a lot to do with regions and total square footage and everything like that. So once again, I'm generalizing on this one.
Yeah, and it will vary by leveler as well. Different grades of levelers, if you will cost more than others, so it can skew the price.
Yeah. For cementitious base, once again, I'm going to generalize it here. You're around that $253-ish dollars. Could be a little bit higher, could be a little bit lower. Depends on the size of the project. Depends on the leveler that's being used, depending on whether there's spot pouring or full flood pouring. So there's a lot of generalizations in there, but from an upfront cost, yes, gypsum looks cheaper, but there are some additional work that goes into it. Cementitious does look a little bit more expensive, but there's generally less of the additional prep work that has to go into it. Moving on to the different types of cementitious self-levelers, we've got our economy grade. This has got the lowest compression strength out of all of the cementitious self-levelers, but to fall within that ANSI standard, we're still a minimum of 3,000 PSI. And generally, we have minimum pores of 1/4 inch. Reasoning behind that is it has a thicker aggregate to it, so we're not able to get as smooth as a high performance. These can go from a feather edge, generally up to 1.5 inches, and they have a higher compressive strength. The high performance grade self-levelers, these are your workhorses that we're seeing for a lot of full flood multi-residential pours, malls, things of that nature. We have deep pour self-levelers. These are self-levelers that can be poured in some cases up to 4 inches in a single go. This is great because it alleviates the need to have multiple pours over multiple days. You can just do a single pour. Yes, once again, there's a higher upfront cost, but you're not having that downtime and the weight of having to do multiple pours. We have self-leveling toppings. These have the highest compressive strength out of all the self-levelers that exist. These can also be used as temporary and permanent wear surfaces. They can have decorative coatings added into it. They can be polished.
How high can that compressive strength go, John?
I've seen it
5,500
PSI,
7,000
6,000,
Yep.
if not higher.
Yep.
6,000 PSI?
6,000 up to 7,000 in some cases. There's some very specific ones that can go as high as 7,000 PSI.
And what about gypsum?
Minimum 2. If we get to 1,000 PSI, bonus.
About 335.
Yeah, generally around 3.
Okay.
We've got rapid setting self-levelers, kind of as it states in the name. These are rapid curing, so in turn we can get on top of them faster. So whether it's sheet goods or tile or whatever it may be, these are great for common areas, renovations, TI improvements where we have to get the turnaround really quick. In a previous life, when I worked for a flooring contractor, we use these a lot for 1-bedroom, 1-bath condos because Mrs. Jones needs her bathroom by the end of the day. So we can self-level and get the vinyl and or tile down that day, and she can go back to using her washroom instead of having to find other uses. The last major type is lightweight self-levelers, kind of like in the name. If there's a lightweight component to it, so they're great once again for renovations or restorations. To break down the different types of self-levelers and to go into a little bit more depth into each, we'll go back to kind of economy grade or an economical grade self-levelers. These are your more cost-effective or most cost-effective options to fix your substrate. They are ideal for anything from Mrs. Jones's house to multi-residential, where they've got to get in and out quick and cost effectively to get that floor as flat and clean as possible before the rest of the trades are coming in. They're great for, in some cases, replacing mortar bed installations, which is more of an older style of installation. Great for floor full flood installs, going back to that going back to that multi-residential. Generally speaking, though, with the economical grade, we're somewhere between 1/4 inch to 1 inch thickness in pour. They can't really sustain themselves past 1 inch thick. And because their aggregate size is the size that it is, we can't go any thinner than 1/4 inch. The high performance self-levelers, these are the workhorses of the self-leveling industry that the manufacturers make. They have a higher compression strength than an economy grade. They have a higher flexural strength in a lot of cases. They can create a smoother surface. They can go with feather edge or 1/16 of an inch up to 1.5 inches. And the reason behind that is because the aggregate is sieved multiple times, in some cases 3, 4, 5 times, compared to an economy grade, which may only be 1 or twice. So it's got a much finer aggregate to it, allowing us to go to a smoother finish. Great for
They typically
both
have better flow rates too.
Yeah, so better flow rates as well. Yeah, ideal for wood or concrete construction. Ideal once again for both residential or commercial. Deep pour, as I said, deep pours are great because they can eliminate the need for multiple lifts. It doesn't happen every day, but there's been a couple of projects that Lewis and I have been involved in where it nicely shortened how long it was going to take to get that floor within tolerance, because they were able to do a deeper pour in a single pour rather than multiple shorter lifts. Yes, some self-levelers can have aggregate incorporated into it to build it out, but this is a much nicer way to achieve that. It can, as I said, because it's speeding things up, because we're doing a single pour rather than multiple lifts, it can reduce overall costs. Yes, there could be some higher additional costs for the material itself, but once again, longer overall costs are coming down because there's less time waiting. Can be used, as I said, to replace mortar bed applications. And in some cases, depending on the manufacturer, we can go up to 4 inches in a single pour without the need of a reinforcing lath or any sort of added, I guess, just reinforcing is the best way to explain it, built into it. Concrete toppings, these are your highest compressive strengths. As we were discussing, they can be up to 7,000 PSI compressive strength for a product. They can have pigments or colorants added into it to give decorative swirls or colors or patterns, whatever it may be. They can be polished or they can have coatings put onto them. One thing though, and I'll let Lewis dig into this a little bit more, but generally with concrete toppings, if they're going to be polished or have some sort of coating put onto it, an epoxy primer is highly recommended to ensure that that self-leveler is going to stay bonded to its substrate.
Yeah, it's an epoxy primer with sand broadcast to rejection. Just because if you're polishing these overlayments, they typically require a large heavy grinder and that aggressive shear action. That requires the epoxy primer to hold it in place and prevent dislodging through that polishing process.
Yeah, the best way that we all like to tell everyone, if you're having to use an epoxy primer, and as Lewis said, do a full sand broadcast, when that sand goes down, we want it to look like a beach. That's how much sand you're going to require on that epoxy primer before a self-leveler is going to go over top, to ensure that we've got that bond strength to the primer to mitigate any issues of having it delaminate during polishing.
And what you mean by to rejection is that literally no more sand will stick.
Yep.
Yeah.
So you
Yeah.
just
As I said, I want it to look like a beach.
Yeah.
Yeah. Typically you come back the next day, sweep off the excess and vacuum anything that's loose, and then you're good to go.
Right.
Rapid setting, much like as the name says, these are fast curing self-levelers. Great for that Mrs. Jones's place, as I keep bringing it up, or malls or common areas where they're only able to shut down certain sections at night between when they close and they have to reopen. Great to be able to get in, get that floor fixed. In some cases, depending on what the final flooring option is going to be, able to get that floor put down over top and turn it back over for public use.
Yeah, the one thing to note, these typical rapid setting ones, they typically have a shorter working time with them. So just something to be aware of when planning your installation.
Mm-hmm. Yeah, these are not ones where you've got one guy mixing a bucket, pouring it on the floor and going back to mixing again, because you may not be able to tie one bucket into another. You're going to have, and once again, sorry to bring up from the tile side of things, but you're almost going to need to have an epoxy train or a self-leveling train of multiple people working one after the other, pouring bucket after the other to ensure that everything can tie together. Because as Lewis said, it is a rapid cure to mitigate any issues of one batch mixing into another and not cohesively bonding, I guess is the easiest way to explain it. Lightweight levelers. These are very specialty based products. In cases like this, some of the raw sand is being removed from the self leveler, and lightweight components are being incorporated into it to give it a lightweight. In some cases, while the bag is the same size of volume as a traditional 50-pound bag, it could be 20-30% lighter than what that 50-pound bag would be because of the incorporated lightweight component to it. These are really good, and I see it a lot in Vancouver, and I see it a lot in Toronto as well, where we have older buildings or big commercial towers where someone is taking over an entire floor and there was carpet tile down there now, but they want to put tile over top. Having lightweight self-leveling underlayments in some cases can alleviate the need to bring in a structural engineer to see if the columns are going to be able to take the additional weight because of the reduced overall weight of the product itself. Restoration projects are a great example of this, or heritage projects are a great example of this, where you've got 100+ old buildings. They may not be able to take the weight of a traditional self-leveler. In a lot of cases as well, because of the additional components that are put into it, we can go 2 to 4 inches in some cases in depth in a single pour. So similarly to a deep pour self-leveling underlayment, but having that lightweight component to it as well. And from an architectural standpoint or a specification standpoint, we may not care as much, but for guys like Lewis that used to be on the trades and on the tools, it's lighter. Doesn't hurt your back or your shoulders or your arms as much. Or the good case study that Lewis always likes to break up is, and especially right now, you got a skid of this in the back of your truck, you're burning less gas because it weighs less. And I don't know the last time anyone checked, gas is really expensive. So any way to try and save some money on it. Last major type of self-leveler that we're going to talk about is fiber reinforced self-leveler. These are self-levelers where they either have a fiber component incorporated into the bag straight from the factory, or you're buying a self-leveler and then a separate bag of a fiber component that you're incorporating it into it. These are fantastic for wood substrates, because in a lot of cases, going over a wood substrate, you no longer need a wire lath or to be incorporated into that self-leveler. You can pour directly over the plywood, and that fiber component to it, or that fiber characteristic to it, eliminates the need for a wire lath. These are also fantastic to go over heating systems because of their flexural characteristics to it. They tend to thermal cycle a lot better than some of the other products that exist within the market itself. Two terms that I see thrown out a lot within the specification in the architectural world are what's an overlayment and what's an underlayment. Chris, you and I have had conversations on this for hours on end, but it's always good to bring up. The simple answer to it, underlayments are going under the final floor. Overlayments can be a topping. Generally speaking, underlayments have a lower compressive strength to it because they are not being used as a final wear surface. Where an overlayment, once again, you can be north of 5,500 psi compressive strength because it's being used as a wear surface. Some underlayments can be used as a temporary wear surface, but they are not designed for day in, day out wear and traffic across it. It's something that can be temporarily used until that final flooring is being done, where an overlayment can be used as that wear surface, whether it's a polish or a coating that's being applied over top. Moving into some of the different, I don't want to say nomenclature, but the different characteristics, once again, of the cementitious self-leveler and how we, from an architectural standpoint and a specification standpoint, gauge self-levelers against each other are their compressive strengths, their tensile strength, and their flexural strengths. Both tensile and compressive strengths are dictated under ANSI A 118.16. From a compression strength, this is 1,000 psi after 24 hours and 3,000 psi after 28 days. From a tensile strength, 73, we'll round up, after 24 hours and 145 psi after 28 days. These are to ensure that, kind of the name of this presentation, not all self-levelers are created equal. Certain self-levelers are going to perform better in certain areas. So that's why these tests exist. And in a lot of cases, it's tests that we've taken from the concrete industry. But so we can ensure that what's being specified and what's being installed is going to perform as the ownership group needs it to perform.
And those are minimum standards.
Yeah, and these are minimum standards here. So once again, going back to that ANSI 118.16, any cementitious self-leveler that has to meet 3,000 psi after 28 days to comply with that standard, amongst other things, but something to be aware of. Flexural strength is a little bit different because it doesn't fall under that ANSI 118.16 standard. However, generally speaking, we see somewhere between 500 to 1,400 psi, depending on the type self-leveler and what it's going to be used for. On the right-hand side of the slide, you can see some of the different test methods on how we're going to achieve that. This is another photo here of showing how, in a simple term, how we're testing the self-leveler to be able to work, whether it's compressive or tensile or whatever it may be. Pore thicknesses. Once again, not all self-levelers are created equal. Generally speaking, over a plywood substrate, we need a minimum of a 1/4 inch thick self-leveler. We're also, generally speaking, going to require a wire lath to be embedded into that self-leveler unless a second layer of plywood is being installed. Then it may not be required. However, depending on deflection ratings, that wire lath still may be required. Some of the some of the fiber reinforced self-levelers, they don't require a wire lath at all. So something to be aware of depending on what we're looking at. Concrete, once again, we can go from a feather edge up to 4 inches. And to some degree, much like plywood, but concrete more so, we really need to be concerned with there are no contaminants or bond breakers or anything like that on the surface of that concrete or embedded within it, because it can lead to a delamination. Thicknesses going over hydronic heating or heating systems. Similarly to plywood, we need a 1/4 inch minimum over the top of the cables or the tubes to ensure that they are fully encapsulated into it. Wire lath is not required for installations like that because the tubing or the cables kind of act as the wire lath. But understand that some cementitious self-levelers they're not recommended for heating systems because they are not as dimensionally stable, and there's a higher probability of cracking that could exist. I think, Lewis, you wanted to add in 1 or 2 things with
Yeah,
that?
just exactly that they can crack through the thermal cycling of the heat systems as it heats and cools, can cause that leveler to crack. It's typically where fiber reinforced levelers perform the best.
Thank you. Yeah, and this also kind of goes in play. There's some heating systems, name I won't mention right now, where it's plywood that has grooves cut into it and then sometimes a plastic film over top. This is where we have to be cautious about what sort of self-levelers are going over top to keep the rigidity and keep that thermal cycling in check. Last one, uncoupling mats or uncoupling membranes or heating mats. Similarly to plywood, similarly to hydronic heat, we're looking for a 1/4 inch pour over the top of the dimples. Primers are not recommended for these types of installation because of how the self-leveler bites into the little squares or circles or the dimples themselves. However, if it's a peel and stick uncoupling membrane, self-levelers are not recommended for this because, much like concrete, as self-leveling cures, it shrinks slightly and it could cause that peel and stick membrane to pop. Mark or timestamp this of beginning of 2025. A lot of manufacturers are in the process of testing self-levelers with peel and stick underlayment, so that recommendation may change slightly in the future, but as we stand right now, if it's a peel and stick uncoupling membrane, it is not recommended to self-level over top. Key considerations that we need to look at is what's the final area going to be used for? Are we self-leveling a warehouse? Are we self-leveling Mrs. Jones's house? Is it going to be a hospital or high point load environment? That can help steer and dictate what type of self-leveler is going to be used because of all the characteristics that we've talked about in the past. I'm not going to use the same economical grade self-leveler that I would for Mrs. Jones's house as I'm going to use at a hospital because of the performance characteristics that we're going to get out of a high performance or a topping self-leveler compared to an economical grade one.
Yeah, sometimes in hospital applications, especially in areas where the MRI machines are, CAT scan machines, they require a super flat surface. This is where you may want to consider a leveler that is a higher flow rate to achieve that flatness, higher compressive strength because of the weight of the machines. Just would be a much better option than the more economical one.
Yeah. Similarly, with the vein of hospitals, are we going to have rolling point loads? Is there going to be static point loads? What's that looking like? Especially in hospitals, we're seeing higher compressive strength self-levelers being specified because the machines that are either sitting on the self-leveler in the flooring itself or just the gurneys going back and forth, there's a lot of rolling point load there that can cause a degradation of the system over time and in turn lead to a failure. What do we need that floor flatness to be? Are we looking at an FF35 of a 1/4 inch over 10 feet? Do we need an FF60? Do we need an FF100? As Lewis said, MRI machines require an FF100. Certain self-levelers may not be able to get to that desired level, so we're going to have to look at certain options. What flooring is being used over top? If we're going with an economical based self-leveler that has a larger grain structure to it, they may have to skim coat over that if they're putting, say, a resilient floor over top. Where going with a high performance self-leveler that has a finer aggregate to it, you may not need to skim coat over top before you put your vinyl down to ensure that you're not going to see the telegraphing of any weird undulations from within. What's the substrate being used? Once again, we talked about that. And whether we're full flood or spot leveling. Certain self-levelers are going to perform better on full flood versus spot level because of their flow rate, because of their mix rate and everything, and how they're going to heal and tie into each other. Concrete versus plywood. As I've stated, wire lath is generally required for plywood installations. We have to ensure that that plywood substrate meets the minimum deflection ratings prior to any self-leveling going in. Yes, self-leveler can help fix with deflection ratings, but we can't have a super wonky floor and then hope that just putting weight on it's going to fix it, because it's not. One thing that we get asked a lot is, can I self-level over strip hardwood or parquet? No. That has to be either ripped up and removed, or depending on what it is, encapsulated under another layer of plywood before we self-level over top. Concrete substrates, generally interior concrete only. Yes, there are some one or two oddities where you can, self-levelers are designed for exterior use, but generally interior use only. Primers must be used, and we need to be aware of curing compounds. This is a big one. Lewis and I have dealt with this off and on over the years, where, especially with tilt-up construction, those bond breakers that are sprayed onto the concrete and then they try and self-level over top and they wonder why it keeps breaking free. Well, got a bond breaker on it, and the primer won't stick to it and the self-leveler won't either. So know what your substrate is and how to prep for it prior to any work that's being done. A little bit deeper into the wood substrates. Seems common sense, but common sense isn't as common as it used to be. Plug all the holes in the floor. I get a real chuckle every time I hear a story about someone that self-leveled and they didn't plug their in-floor forced heating and it all went down the drains. I think it's hysterical. Mrs. Jones does not. Ensure that you're using expanding foam around all the areas where you don't want self-leveler to get into. Ensure that if it's a TI improvement or a renovation, or to some degree even a new construction, that plywood substrate is clean of all contaminants. All the joints have been prepped, and that if required, lath is there to be incorporated into the assembly. From a concrete standpoint, you know, I'm going to keep harping on this. You have to make sure there's no curing compounds or dust or any other contaminants that are on that concrete. Confirming that the right CSP or concrete surface profile is present on the concrete prior to installation. Test to see if the concrete is porous or non-porous. This is a little bit less to do with the concrete and more to do with the primer, but this can dramatically change what type of primer is being used depending on whether it's a porous or non-porous substrate. And lastly, testing for relative humidity and vapor transference transmission from that concrete. It can affect what primers are being used. Worst case scenario can cause delaminations of the assembly itself. I think everyone on this presentation has seen this slide before, but this is what we're talking about with concrete surface profiles. With self-leveling, we're generally looking for a minimum of a CSP 3. Sometimes it's a little bit higher if we're doing a polished topping, but generally base minimum CSP 3.
Hey, Lewis, what do you consider a CSP to be when you've sand broadcasted?
A sand broadcast would probably be closer to like a 6. So
Okay.
yeah, 6 to 8. No, 6.
Something that gets overlooked a lot with concrete construction, but especially as we're seeing more rapid pace construction, is ensuring that we're doing moisture testing and moisture mitigation within the assembly itself. This is obviously a precursor to any self-leveling that goes down, but something to be aware of. We need to test for vapor transference coming through that substrate. There are multiple different ways on how we can test that, but it is something that needs to be done. We need to test for relative humidity. One of the key things that, once again, always gets overlooked, and I know, Chris, you harp on it a lot, but ensuring that the building is closed in and the HVAC system is operable or turned on, because if not, we're going to get faulty readings. You're not going to possibly get the moisture draw out of the concrete. Also, using what I'll dub third-party heating systems, whether it be a propane or electric or something to heat that room. Be concerned about that, because propane heat can add moisture into the room, which can cause some interesting results, I think is the easiest way to explain it. So ensuring that we are where we need to be, with that HVAC system turned on, with the building enclosed, that the primers are going to cure properly and the self-leveling is going to cure properly, and any moisture that may be trapped within the concrete or below the assembly itself has, for lack of a better term, evaporated out of the assembly.
How are you guys? I see your slide sort of speaks to it, ASTM 2659. You know, that's another thing I keep harping on about is ASTM 1869 and 2170 are not enough on their own to guarantee a dry surface. How do you feel about that?
I would 100% agree with that, Chris. The 2170 is if you're going to have to do a standalone option, it's obviously the best option. But incorporating all three of the major test methods multiple times through the installation is going to get you the desired result that we're looking for.
Like, honestly,
especially
that Tramex device is the flooring contractor's best friend. It's just, it's shocking how few know about it and how even fewer obviously use it. And yet the risk, the roll of the dice to proceed with the other two methods that are good in their own way and not knocking them, it just, you have to include the electrical impedance test on top to get a guaranteed result.
Yep. Yeah, managing dew point as well, and pH testing.
I mean, that alone, Lewis, so you can't manage dew point with the other two tests.
Yep.
And just, it's a big topic.
Yeah. And as we were discussing before the presentation, you know, with these company that begins with T, I'll keep this neutral, testing methods, they're not that expensive. They're a couple $100 at most, what, $1,000, $1,200, something along those lines. They're not overly expensive, and having one of those in your arsenal and being able to use it is significantly more cost effective than having a failure and you have to go back in and replace it.
I remember
Sorry,
I was going to say, back in the 90s when I was contracting through the 2000s as well, I worked for a wood flooring contractor, and we used an electrical impedance testing device that at the time in the early 90s cost us $2,500. And our installations hung on that thing saying dry or not, go or no go, and never did a drill test or an MVER test to decide. It was all about the electrical impedance test. So I think today a good quality impedance testing device will cost you $1,200, will pay for itself in no time at all.
Very true. The great thing with a drill test or one of the in situ related tests is, in a lot of cases, these have kind of an active life to them. So you can go back multiple times throughout the installation, and I don't want to say reignite but you can reread what that device is reading within the concrete itself as it continues to cure out, as the seasons change and everything like that.
Yeah. Well, some of the in situ probes, they're now Bluetooth, and you can leave them in there and just have a continuous log of it.
Yeah. I think that's what they were always intended to do, was monitor curing, internal curing of concrete, to make sure you had a healthy cure happening. Healthy cure means strong concrete.
Correct.
One big thing with this, and to go back to the architectural and specification side of things, is from a trade standpoint, if a GC goes, okay, you need to test the floor, that's not on you. That's within the big documents. That's within the GC's responsibility to ensure that that substrate meets the standards required for you to put your tile, vinyl, sheet goods, self-leveling, everything over top. It's a good idea to do your own tests for that cheat insurance, but it does fall back on the GC's responsibility to ensure that that substrate meets the requirements prior to installation. And that's something that I have to argue with a lot with GCs and architects for.
Well, spec writers often get everybody into trouble by putting responsibility for 2170 testing and 1869 testing on the flooring installer in Division 9. You know, if they also specify NFCA standards or specifications in that same project, quite often I've phoned the architect and said, look, either change the requirement for the installer to do the testing or take NFCA out of the spec because they're in direct conflict with each other. I haven't seen NFCA deleted as a result of that yet. The architect or spec writer literally says, oh, I didn't know. Thanks for the heads up. We'll issue a change order and place the responsibility for that testing where it should be, where it's logical, which is with the general contractor.
Yeah, there are third-party companies that can come in and do it on behalf of the trades and the GC, and that's great because then you've got a third-party company. But
yes,
the onus does rely or does fall back to the GC.
Yeah, we're absolutely not saying the GC should take those tests. They should use a third-party testing agency to do that. That removes all the conflict.
Moving on to the last couple of slides, we've got moisture mitigation. You know, if there's a high moisture, why is there a high moisture? Where is that issue coming from? I don't think I have ever walked onto a job site where that 6 or 10 mil poly underneath the concrete hasn't been torn up and ripped up because of trucks driving out over it or just trade damage. But that's what building code requires for a moisture membrane underneath the concrete slab. So don't solely rely on 6, 10 mil, 12 mil poly, whatever it may be. You may have to look at other issues or other solutions. The best, generally speaking, solution of all is having to put a epoxy moisture mitigation membrane down over the concrete to stop any moisture coming through that concrete, causing the system above to possibly delaminate or fail. Some of these moisture mitigation membranes can block up to 100% RH, can block up to 25 pounds per 1,000 square foot of vapor transference. So something to be aware of. And also, once again, ensuring that the building is closed in and the HVAC system is turned on. Otherwise, you can achieve false readings.
Yeah, and making sure that those, sorry, I just want to get in there and making sure that that moisture mitigation is done prior to self-leveling, not after the fact. Should always done before your self-leveling.
Last thing I want to talk about, and this is something that is always overlooked within the industry, but it is movement joints or control joints. I'm going to use the term movement joints very loosely, and building that into your self-leveling. There are some interesting gray areas within that. But once again, this is where we rely back on AESTM F710. This is why ANSI 108.01 is incorporated into it. The new standard for self-leveling placement or self-leveling installation, ANSI 108.21, exists within it. And then we can also look at ACI 302. The resilient world gets a little bit interesting with this one because they're going to look at it from an aspect of if it's a live movement joint or an active movement joint, it has to be honored through the assembly. If it's a dormant movement joint, then it can be buried under the vinyl assembly. But there's no clear definition on what an active or a dormant movement joint is. And once again, I'm using the term movement joint very loosely, but something to be aware of with these installations. From the tile side of things, if there is a movement joint, control joint, construction joint, whatever, in your concrete substrate, it should be honored through the entire assembly, through the tile assembly, and a silicone and or rubber or plastic joint needs to be incorporated into it. The 108.21, this is a new standard. This has come out, as I said at the very beginning, in conjunction with the standard for self-leveler. That's now showing that if there's a movement joint in your substrate, it has to be honored through the concrete substrate itself.
Yeah, and including around abutments, if you're meeting up against abutments, columns, there should be an expansion there as well around those columns or those abutments. There should be a joint there as well. Shouldn't be level tight to those abutments. You got to give it room to breathe, allow for creep and crawl.
Yeah, so a great example or a great little detail of that is here on this slide in kind of the center left, where it's showing a column in the middle and then diamond isolation joints around it, and then those construction joints moving out from each point. No, the main goal of those movement joints is to help with getting the concrete and in turn the self-leveling, if it's going to crack in a specific area. We're trying to guide it in a certain way, and so we can mitigate that through the assembly. Through the, I believe it's the ASI standard. Generally, spacing, if you've should be 2 or 3 times the thickness of the slab is what your separation should be of movement joints. So the example here, if you have a 4-inch thick slab, you should have movement joints every 8 to 12 feet in both directions too. Don't just have them run linearly.
But if it's self-leveling, the self-leveler has to be cut all the way through to the concrete slab.
Anywhere where you have a change of plane as well, there has to be that isolation joint or that control joint put into there, because obviously a vertical substrate is going to move different than a horizontal substrate. So it's something that doesn't get looked at a lot from a self-leveling standpoint, and that's one of the reasons why I wanted to bring it up in this presentation, because movement joints do have to be included into the assembly. It's very quickly overlooked. Most people will just pour over movement joints and then wonder why their system delams. It's because they're trying to bury those movement joints, and they need to be honored. They need to be brought through the assembly. How that's finished from the final flooring option, some of that is dictated back to the manufacturer of the flooring, whether it's sheet goods or carpet or hardwood or tile or whatever. So refer back to TCNA, refer back to the manufacturers, refer back to TTMAC, whatever it may be. So in conclusion, we've looked at ANSI and ASTM standards. We looked at gypsum versus cementitious base. We've looked at the different grades of self-levelers, where they should be used, how they should be used, how thick they can be poured, how thin they can be poured, compressive and flexural and tensile strengths, concrete versus plywood substrates, moisture mitigation, and movement joints. And with that, I open the floor.
Tremendous, John. And Lewis, thanks very much. A wealth of information. Yeah, any questions from the audience? Do have one typed out here by Clayton. Can moisture testing be done after the leveling is applied, considering the application of leveler can be done at a lower temperature, whereas moisture testing has to be done at service conditions?
I would suggest as to which type of testing you're referring to. If it's impedance testing, like you're talking about, that can be skewed depending on how soon after you pour, because the leveler would still be curing out. That's where I would refer to the manufacturer's recommendations on their cure rate. So, and when the testing can be done.
Yeah, I guess the challenge comes when, if you've got half an inch of topping, you don't really know how thick the slab is unless you've got obviously the accurate information from the builder. So, 40% depth or 20% depth for the drill test can throw you off. You can end up spoiling your results if you don't get all that right.
Yeah, and if you're going down, if you're doing an RH test, you're going down into the slab. That's typically different. But if you're doing calcium chloride impedance, then you could get skewed results. And different grades of levelers could cure at different rates. So again, that's where I refer back to the manufacturer.
I mean, if let's say the slab, you for some reason you need to test that slab.
Hmm.
You've done it before. Now you're getting different readings. You're back into drill testing, but the level has been poured. Maybe it's a half-inch of thickness. Do you jackhammer that half-inch out of the way, or do you just
Nope.
drill right through it?
Drill right through.
And that
Yep.
becomes part of your 40% or 20% calculation?
Yep, correct. Yep, we've gone through. It doesn't become, because you want to go into the slab. So it's like the RH test, just 2/3 of the thickness of the slab. It still remains. It's not the leveler, it's the actual slab itself.
So you still do the 20% into the slab or the 40% into the
100%.
slab. Forget the
Yep.
half-inch leveler.
Yep.
Okay.
Yep.
Clayton added, a moisture meter test and plastic sheet test is typically required for any toppings, gypsum or concrete, not exceeding 2 inches thick. There you go. But levelers can vary in thickness. Yes, they can. It's,
Very
you're
much so.
into the randomness of construction.
Yep.
You can't plan for that. So you just have to pivot as best you can on site.
Yeah, it's recommended to always test prior to leveling. It's always the best, because then if you're going to do any moisture mitigation, you got to do it before you level.
So I got a question about temperature, like base slab temperatures. Different levelers will accommodate colder or warmer temperatures. Is that right? I mean, I hear the standard is around 10 degrees Celsius.
Correct. Yeah, that is the typical standard, is minimum 10 degrees. It's not ambient, it is the slab temperature, because the leveler will feel whatever that slab is. If it's an ambient temperature of 12 degrees, but the slab is sitting around 6 or 8 degrees, it's going to feel the 6 or 8 degrees. Primers as well can be affected by slab temperature. So we have to have that slab. And the general rule of thumb is 10 degrees.
Are there products that accommodate 6 degrees?
There are
Not in our line,
some manufacturers,
but some
there are
do.
some
Yeah.
manufacturers that will say that they can accommodate a lower temperature. But what we run into is the acrylics or the latexes that are in self-leveler to act as glue. They generally stop working at around 6 to 8 degrees, and they won't crystallize out. So, or if they do it at a much smaller rate. So you won't achieve that minimum shear bond strength that's required for the installation.
The colder, the weaker the bond.
Yeah.
Correct.
Yeah, much like with glues or mortars for tile installation. Yeah, it may work, but you're not going to get what's written on the side of the box or bag.
Yeah. It's mostly affecting the primer, is it? Or would it be both the cement mix? Yeah.
Yeah, it would be both. Yeah, it's going to take longer to dry out for the primer at a colder temperature. It can affect the primer where it can crystallize if it's too cold, especially if you get into freezing temperatures. So, and then with the leveler, you won't get a leveler that'll perform as well. The warmer it is, if it's a warmer temperature, it'll flow better, heal better. Colder, it won't flow properly. You'll get reduced healing rates. Yeah, it just doesn't function as well.
Any
It could result in more mitigation, more remediation after the fact.
Yeah, this also goes back to the difference of gypsum versus cementitious base. You look at gypsum base levelers, they cure through evaporation, where cementitious base, they cure through hydration. It's that chemical reaction within it causing it to cure out. So if it's really cold and you've got a gypsum leveler down, yeah, we may say it'll cure out in 3 to 4 days or 4 to 7 days or whatever. But the colder it is, the longer it's going to take for that water convenience to evaporate out of it.
So let's say I have 12 degrees Celsius and I pour a half-inch leveling compound at 3 o'clock in the afternoon, and at 3 o'clock in the morning, the heat's off, everyone's gone home, and it's now gone to 5 degrees. Is that a concern?
If it's cementitious base, it's a little bit less of a concern because once again, depending on the type of cementitious base leveler, it's already started to get to a point where it's, depending on the type of self leveler, you may already be able to tile over it because you've had, it's started to cure for 12 hours. But ideally, no, that heat needs to stay on for at least, what, Lewis? Well, at least 3 days minimum.
Yeah.
What, after pour?
Yeah.
I would suggest that, it depends on the cure rate for the leveler. Some levelers can take longer to cure out, like Steve is talking about here with gypsum levelers can retain moisture, right? So if you've got a gypsum based leveler, the longer you have it at a lower temperature, the longer it's going to cure out. The warmer it is, the warmer it's going to cure out. Even with cement based levelers or calcium aluminate based levelers typically cure out a lot faster. They generate heat, but the cooler it is, the slower it'll cure out, right? So it depends on what your finished flooring is, how fast track you want your project. If you can maintain heat, keep it at a minimum 10 degrees, then you can keep your project moving at a steady pace.
Maybe expand on the difference between cure out and dry.
Or dry out, if you will. Sorry, dry out. We're looking for dry. So some levelers will dry where you could put moisture sensitive flooring in anywhere from 16, 24, 32 hours. Depends on how thick you're going, depends on temperature, humidity. The slower it is, the longer it's going to take. The lower the temperature, higher humidity, the longer it's going to take to draw before you can put that moisture sensitive flooring. So if we can control those temperatures, then we can maintain and get that finished flooring on quicker.
Because cured is going to be a term that's much more likely to be quantified through the instructions that you get with the product. It cures in this much time, whereas if you say dry, it's like
dry. That's right.
Piece of string,
Yeah.
It doesn't
Yeah,
come with
because cure, we're looking at 28 days for a full cure, right? With most cementitious or calcium aluminate based levelers. So, but for dryness, before we can put our finished flooring on it, it varies based on product and manufacturer.
Okay.
Just a time.
I would have to, yeah.
Sorry, just a time check, guys. It's at 2:08.
Yeah, no, that's good information. Everyone, often we're asked, we want to put some leveler down. How long does it take before I can go over top of it?
Yeah.
And it's interesting whether it's okay to go over it, whether it's dry versus cured.
So
Chemically.
Sorry, not to interrupt, Chris, but if we have one product where if it's at minimum 10 degree temperature, 50% humidity, we can go on it with moisture sensitive flooring as early as 24 hours. Another one we have is 16 hours.
Even though it might cure for the next 20 plus days.
Correct. But you can go on it with the moisture sensitive flooring because it's designed with calcium aluminate to dry out quick enough that we can go on it.
Yeah. So in the world of concrete, cured, as we've learned, means it's reached design strength, compressive strength. The same in the world of HCU, hydraulic cement underlayments?
Correct.
Okay,
yes,
good.
The same.
Yeah. What else we got here? I had a gypsum job that was not drying out. Found out that temperature was too low and humidity too high. The gypsum drying stops until ideally the humidity is 30 to 40% and temperature 20 to 30 Celsius. The hotter it is, the more likely it will crack.
Correct. Yeah.
Again,
refer to manufacturers, but ours, we sit around 32 for maximum temperature. Because if it dries too fast, it can crack, right? That's where you want to avoid direct sunlight. Make sure that you have your doors, windows closed to avoid any wind blowing over your leveler. That will help mitigate any cracking, any issues as well.
Good stuff. Any other questions from the group as we close in on wrapping it up?
Bob Hunter has asked a question.
Oh, where is that? Can you read that, Lee?
Yep. How is the PSI affected when you say you can lay over it when dry versus cured?
At the dry state, it's at a lower PSI rating, but it's not blowing off humidity where it'll affect the finished flooring if it's a moisture sensitive flooring. Cured rate is at the fully cured 28-day where it reaches its maximum PSI strength.
Yeah. So once again, I'll use a compressive strength standpoint, but after 24 hours, you're sitting at 1,000 PSI. You can put your moisture sensitive flooring possibly over that or whatever it may be. After 28 days, it's going to continue to cure to that minimum 3,000 PSI with a flooring over it. It's not going to affect it.
Yeah. Yeah, I think our spec ran it for a while, but our spec with regards to gypsum and cementitious underlayment states it must cure to a certain PSI within a certain number of days. Correct. So you can plan to get, active on that surface again.
Yeah. Yeah. Clayton's comment there about placing heaters on the floor, is that before or after or during? After, yeah. After the fact, like after placement, immediately after, in order to accelerate cure, not recommended. Absolutely not recommended, because again, you could be prematurely curing out the surface where they're, depending on how the thickness of your pore, the underneath of it could be still in a wet state, and you can cause cracking on the surface.
Very
Correct.
good.
Yep. Excellent.
All right, guys. Well, unless there's any more pressing questions from the group, I think we'll let you off the hook. And thank you very much for your time and wealth of knowledge. It's lots of information. I love it that we get to record this stuff. And we actually had the professional interior designers out of Manitoba said that they're going to apply CEUs to the recorded content on our library, which is, hey, free of charge.
Excuse me. Sorry, Chris, I'm just going to stop the recording.
Yeah, sure.